We have, so far, everything we've done, we have a leading coefficient of 1 in all the polynomials that we have factored. Obviously, in reality, you don't have that all the time. So what do? Well, if we took the zeros of, well, here's our polynomial, 15x, blah, blah, blah. It factors to this, 3x minus 2, 5x minus 8. And I said, what are the zeros of this, i.e. what makes each bracket 0? What makes 3x minus 2 0? 2/3. What makes 5x minus 8 0? 8/5. Okay. If I multiply 2 and 8, what number in the polynomial do I get? What's 2 times 8? 16. You get the constant term. If I multiply 3 and 5, what do I get? 15. So I'm really burning through this because the important part is at the bottom. So if you go to the very bottom, this is called the rational zero theorem. Rational because we're rational numbers, which means fractions. Basically, it's telling you, how do you get the starting point? What do you start with if you have a leading coefficient that is not 1? Before, we just looked at the constant term. We took all the factors of that. If you have a leading coefficient that is not 1, you use the rational zero theorem. It is essentially the same as the other one. It's just the bottom will be 1. And they call it P over Q, but really all it is the factors of the constant term, just like we just did, divided by the factors of the leading coefficient. Okay? So this will make a little more sense when we actually do this. So if we flip the page, or look at the next page, here's our polynomial, 5x cubed minus 51x squared plus 55x minus 9. First thing you do when you're trying to factor this is starting point, take all the factors of the constant term, which they've done for you, plus minus 1, plus minus 3, plus minus 9. Okay, and they only listed the 3 once because it would be 3 times 3. Okay, you only have to list it once. Then you take all the factors of the leading coefficient, which are listed as plus minus 1, plus minus 5. Then to get your possible factors, you divide them, factors of the constant term, factors of the coefficient. So you just write it like this. Boom. And then you divide them. So you go 1 divided by 1 is 1, plus minus 1. 1 divided by 5 is 1/5. 3 divided by 1 is 3. 3 divided by 5 is 3/5. 9 divided by 1 is 9. 9 divided by 5 is 9/5. So these are your potential zeros. Okay? Is everybody with me so far on that? Then to get your potential factors, those are the brackets. So we just write, for the 1, we'll just go x plus minus 1. For the 3, x plus minus 3. And for the 9, x plus minus 9. Now for the fractional ones, we can write them. Normally we would write x plus minus 1/5, but that's pretty ugly. So what's equivalent to x plus minus 1/5 that will give you the same 0? 5x plus minus 1. That's when they say ax minus b, this means n is all natural numbers and b is basically saying no fractions. Okay. So instead of writing x plus minus 1/5, you write 5x plus minus 1. What would I write for 3/5? 5x plus minus 3. So you could write x plus minus 3/5, but that gives you the same 0. And for the 9 one, it's going to be 5x plus minus 9. Those are your potential factors. After that, everything's the same. The potential factors are different, but after that, everything's the same. So show that x minus 1 is a factor and determine all zeros, i.e. factor this polynomial, okay? Okay, so if it is a factor, that means that we're dividing by x minus 1, right? Everybody agree with that? Okay, so let's do synthetic division. 1 goes on the outside. Do I have to add in any 0x to some power? No, they're all the same. They go down in proper order. So I just put the coefficients. Synthetically divide it, drop the 5 down, 5, negative 46, negative 46, and that is 9, 9, 0. So we get a remainder of 0, which proves it's a factor. So if you write it as dq plus r, divisor is x minus 1. What's our quotient? Five x squared minus 46 plus 9. Remainder is 0, so you don't have to write that. Why does this make us happy? Quadratic. Do you guys remember how to factor this? Everybody's going to use different ways. Some people use the boxes. Some people use decomp. If you're doing decomp, you multiply the 5 and the 9, which gives you 45. And then you say, what multiplies to 45 and adds to negative 46? Negative 45, negative 1. So you break up the 46. Negative 45, that should be 45x. Minus x plus 9. And then you do your factor out a common factor. Take a negative 1. You have 5x minus 1 and x minus 9. Remember that you got to bring down the x minus 1. So the factored form is x minus 1, 5x minus 1, x minus 9. And that is the factored form of that polynomial. Okay, the only thing that changed, other than we had to do decomp, is this bit at the beginning. It's factors of the constant term divided by factors of the leading coefficient. That should be on your formula sheet or your study guide or whatever you want to call it. Yeah, are there any questions about that? After that, everything's the same. Plug it in, find a remainder of 0, divide it off, keep going until you get a quadratic, factor the quadratic, you're done. All I want you to do is number 2, and I'm going to tell you to use x plus 2, and number 4, use 3x plus 1, and then x minus 1. And that's it for today. At 20 after, I'll hand back tests, and we'll quickly go through that before the end of class.